Great. Hey, how's it going? I'm Patrick. I like serverless. I like non-servers. I like all servers, not serverless, but serverful. Any servers, really. I just thought about, maybe giving a talk on Python and serverless because we hadn't really talked about serverless, I think, at Python Frederick. So figured I'd put this together and tell you why you should try it out. I'm not saying you have to. And maybe give it a chance. It's not gonna maybe save everything. There's definitely reasons to still have servers around. But as you'll see here, there's probably some pretty good reasons why you want to check out serverless. What is serverless? It's we can read the Wikipedia definition, but basically the idea is, or at least in the definition of serverless, not so much what we'll get into shortly is what's called serverless, the framework. But serverless, the idea is basically a cloud computing company, or even you can kind of build these things on your own infrastructure using something like OpenStack, and I forget what the term is with OpenStack, but they have a serverless capability as well. Kind of abstracting away the need to manage the servers and making the environment do that for you. Maybe the infrastructure side of the house, or in the case of cloud computing, the AWS or the Google or Azure manages that for you. And you as a developer, you just push the code that you want to put out there, and it'll manage the environment for you. That's essentially what serverless is. There are, in the majority of the cases of serverless, you don't care about the servers. They're not there for you to worry about. They just exist. Your code runs on them. You have a few minor things that you can change, like the size of the number of CPUs, or the amount of memory, or in some cases the amount of storage that a serverless thing has. That's really about it. You can inject some environment variables, but you can't change the base operating system. You usually have to specify the execution framework, or in our case, we're going to be talking about Python. So in all cases, you'll see me select that the environment is a Python environment, but they have Go environments, they have Ruby environments. All these different providers have these different environments to provide you. So the idea is that the system is provided for you, and you just use it. There's not too much to customize there. So why serverless? Like I said before, the cloud provider, or if you're running some sort of serverless thing inside your own network, that's provided for you, and the entity that's providing it to you manages the servers. You're not really doing anything with those servers. You write the code, you deploy the code, hopefully easily. Something happens, and then you make money. That's essentially what happens. In most cases, there's unlimited scaling. You'll see in the next slide, or maybe 2 slides from now, where we kind of compare the different cloud providers. In a lot of cases, you can use it for one-off cron jobs, like one of the cases I'll show here later is this cluster notify service that I built that basically kind of saves the company I work for money by looking at all of our accounts, looking for a specific tag, and says, hey, you've got these clusters in this environment, and it prints out the amount of time that it's been online. And if one of those is my cluster and I meant to turn it off 2 days ago and I didn't, I quickly go out there and delete it real quick and save us a couple of dollars. That can be executed every day at a specific time. Or in the case of the scaling up to millions of invocations, you can build a serverless environment that can handle millions of users interacting with it a second. And in the case I'm showing there, if you're interested, there's a thing called serverless artillery. It's a load testing environment that deploys to Lambda. There was another one called GOAD, G-O-A-D, and it uses Lambda to essentially send a large amount of load to your environment. And like I said, if you can use Lambda to handle millions of users, you could essentially use Lambda to create millions of users to test your environment. And I'm not saying you should use that on any other environment, but you could use it to test your environment.
Is that Nordstrom, the retailer?
I actually didn't look close enough, but probably. I mean, you see a lot of these organizations, Walmart, Nordstrom, I forget who is the other large retailer, has really started to build these huge development workhouses. Walmart has one of the highest paid developer firms out there because they need to compete with Amazon. they're building these applications to be able to sell stuff faster. So I wouldn't be surprised if that's Nordstrom, or it's probably just some guy that calls himself Nordstrom. Who knows? We could take a look. Yeah, this is Nordstrom Incorporated, a specialty fashion retailer headquartered in Seattle. Learn something new. And then lastly, on-demand pricing. That's I think the biggest thing about serverless is, in at least AWS's case, it's per invocation. So in the bottom line there, you see 20 cents per 1 million requests. So if a request comes to your serverless application, you'd have to get a million of those requests to happen to cost you 20 cents. Now, obviously, if you start building a much larger instantiation of your serverless environment, that could probably add up pretty quickly. But like I said, if you're using it for one-off cron jobs for some random thing just to keep things in check so you don't have to manage some infrastructure somewhere else, it'll cost you zero. So there's definitely some pretty interesting things as to why you would use serverless to essentially have a zero-cost infrastructure. And the nice thing is, like if at 2 a.m. you have no users, serverless isn't costing you anything, maybe a little bit in storage, but if nobody's using the environment at like 2 a.m., then it's costing you $0. This is a horrible slide on this thing here, but basically when I post these slides, you'll see here, it's kind of explaining the different core providers that are out there. At the top there, it says the version, they're all production ready. They have a whole bunch of different supported languages. This slide ain't that great to show, so I'll just move on. But when I post these slides, or when Matt posts these slides, you'll take a look at this. You can kind of really see a good explanation of how the different cloud providers are essentially providing the same thing. They're just called, in AWS's case, Lambda, in Azure's case, Functions, and in Google's case, Functions. So let's real quick demo something. AWS Lambda first, because who doesn't love AWS? Let's go here. There's the escape key. We'll go to my account here. We'll go to Lambda. And hopefully this shows well enough here. I just have a couple of other functions out here, but let me see if I can zoom this out ever so slightly. Actually, that looks pretty good. So we'll go ahead and, just in the Lambda console here, we'll go ahead and create a function. And we can use a blueprint. And in this case, I have a couple of demos just for using the hello worlds that come with all these different providers here. Python hello. Of course, the keyword doesn't show up. Hello world. There we go. Hello world Python. We'll use that. And in this case, you see we're able to specify Python 3.7, or at least this blueprint's using Python 3.7. I think Lambda supports Python 3.8 now. But they also still support 2.7. So if you're, for whatever reason, still on Python 2.7, you shouldn't be.
A couple more months, right?
Yeah. Well, no, like last month.
Supporting it for another year? Something like that, yeah.
They are?
Python's not.
Oh, Amazon is. Okay. Yeah. I meant to add that slide in where I said you got to download Python 2.7 for this presentation. So we'll just create a function name called test. We'll use an existing role that's out there. And not to get into too deep here, basically the existing role is, Amazon has the idea of kind of like user permissions, but in this case, it's a role that the Lambda assumes to do specific things. I think the basic execution just allows it to create log entries and use a couple other things, but it's very basic, not really important for this demonstration. In this console view with this template, you can see the code here. If you're using some other form of way to deploy this, you really wouldn't want to actually use the console for this if you're deploying to some other environment. you probably want to use some, and we'll talk about this later when we start talking about the serverless framework. All of that is part of the deployment process. So you don't necessarily even need to look at the console. Again, I'm just showing the console here to show you how easy it is to get something up here. So in this particular case, we've just got a very simple Lambda function that has a function called Lambda handler, prints out some values that you pass in, and it returns one of those values. We go down here, we can create function, and it's out there. We now have a very simple Lambda function called test. And we can test that. We'll just create a test event. One interesting thing that you want to really kind of think about when you're talking about Lambda, you can put Lambdas or serverless functions behind some sort of API, like a API gateway in the case of Amazon, where it responds to HTTP requests. But in a lot of cases, you actually want to use Lambda to respond to events. And without getting too deep into the weeds there, the difference between having it use something like HTTP service versus events, in the sense of events, you could see it potentially scale a little bit better, maybe make it a little bit more reactive to something. Whereas maybe an API gateway or some other service is a more traditional way to interact with a service. Neither are wrong, there's just different use cases for both.
Is there significance for that function name you used in Python? Does it have to be that? Or?
No, you can name it. You're smart. I'll show you why in a second. You didn't know you were smart, did you? So I'm just creating this test event real quick, just because we'll sit here and test it. But what you're talking about there is we can specify in this, either as part of the deployment process or here in this handler. You see the name of this Python file is lambda function or lambda underscore function .py. And then in there we have lambda handler is the function. So when we execute this lambda, we're specifying the handler's lambda function, and then it calls lambda handler. You could call that anything. I think in my example later, I think this service is cluster notify, and it's the actual function that it's calling is main. You could use whatever. In this particular case, this is just what it has. So we have our test event here. And we'll go ahead and just click test, and we should see, perfect, it succeeded. We can see the details. We see that we printed, as we saw later down here, we can see here that we printed out the values that were passed in via the test event, and then also returned value 1. So if we look at the code again, we see we printed out, so those print statements above were these prints here, and then the return was that very top one. So we can change this up a little bit, and instead of having this return value of value 1, let's change this return to, let's go with Python Frederick, and we'll just change one of these values. In fact, I'll save this, so we'll return Python Frederick, but I'll change the test event that we send. Instead of having those values that we had before, we'll change those values in the test event, so you can see that why one or the other displays differently. So let's go ahead and configure this test event. We'll change this to Python Frederick. Awesome. So now we've got these 3 values here, and you'll see here now when we save this, we're going to see, instead of the value 1 returned, we should see here Python Frederick, and then down here in this print statements, we'll see value 1 equals Python, value 2 Frederick. Hopefully this actually works. We'll see. Great. So we executed it properly. It responded with Python Frederick. We've got Python Frederick, and awesome. So you can see there we changed the event to have some different information that it passed to the function, and we also see that we changed the function to print out some different information. Very, very simple test. It's as you saw, it's incredibly reactive, very quick. And the interesting thing is, if I were to put this behind an API gateway or something and have all of you hit that endpoint, which will actually probably do later, it'll respond to everybody almost exactly at the same time because it'll scale out those functions to interact with all those different requests that come in. If we go on to the next one, GCP Cloud Functions. I'll be honest, I have more experience with Lambda, but I'm also actually an incredibly big fan of GCP Cloud Functions, specifically because in the previous one, we showed a test event, like using Lambda to interact with events. GCP Cloud Functions, in about 2 minutes, we'll have a hello world in Python responding to REST call or HTTP calls, which is incredibly amazing to me that it's that quick. Let me see if I can remember GCP. I never remember the login to GCP. I don't even save the bookmark to GCP. I've got tons of bookmarks to AWS, but you're a GCP guy. Why don't you come up here and give the talk? Let's go ahead and go to, man, I can't even remember. Hold on. Here we go. Cloud Functions. Perfect. Don't mind the weird project that I've called it. SDFAS is just the closest keys that my left hand can hit when I type on the keyboard. So like I said, Cloud Functions, I mean, when you look at it, aside from it being blue instead of yellow, it's a console. It provides essentially, in my opinion, the same service that AWS provides. There might be some minor differences, but for a basic hello world, it's the exact same thing. In this case, we'll call it function 1. Like I said earlier, and I didn't really show this in Lambda, you can specify the amount of memory, but the interesting thing here, see, it limits out at 2 gigabytes. You can't really, in these functions, you're not able to get 16 gigabytes of memory for these things because you're supposed to build them to be pretty small. I don't know, I was thinking about including a graphic, but I ended up not. It showed, many years ago, there was the idea of these monolithic architectures that were just an all-encompassing application. And then they started doing the whole microservices move where you've got Amazon with its microservices and the 28,000 microservices that they provided. Now you've got these functions where you've got maybe 100,000 functions. Maybe that's kind of an overstatement. But as you see the progression of these instantiations of these environments, the monolithic architecture required 48 gigs of memory to run. The microservices architecture had, maybe a couple of microservices that required 8 gigs, a couple of microservices that maybe required 16 gigs. The rest of them required, 2 or 3 gigs, and a couple of each of those had a certain amount of virtual CPUs that they required. With functions, they're even smaller. Maybe in this particular case, and in fact, I know with AWS it's this case, probably the same for GCP. You see that we're only able to specify the amount of memory. In AWS, you specify the amount of memory, which ends up in turn specifying the amount of CPU that you have. So the more memory you allocate to a function, the more CPUs it gets allocated. Really, all we care about is the amount of memory. In this case, for this simple test, we can do 128 megabytes. And it's just, that's really the only resource configuration that you have, is the amount of memory that you have for this function. Again, remember, you're writing a very simple function. You should try to scope this thing to a very compartmentalized thing that probably only needs 128 gigabytes to really work with. In this case, we're using for this trigger is HTTP. We have a couple of other ones. I don't necessarily need to go into all the details here, but there's a pub sub capability where you could have it listening to some sort of event pipeline like we did with AWS. In this case, we'll just use a HTTP trigger, and it'll automatically create that URL for us, and we'll show what that does here in a second. Authentication, we're just going to allow unauthenticated invocations, so that URL, that when it gets posted, it's there for anybody to hit. And like I said before, we'll just use the inline editor and a very simple Python hello world. In this case, this hello world is just creating a request. It's using requests, probably some sort of, it's built in. It's not so much the request library, it's just the term request. It's getting the JSON from it, saving that off, and if the request arguments include a message, it'll print that message. If there's not so much an args, but some sort of message in the JSON, it'll return that. Else, if there's no message, it'll just return hello world. Pretty simple. And like I said earlier, we're using Python 3.7 for that. And the function to execute is just hello world. Kind of what you were asking there before. We can change that to whatever, and then you specify the function to execute there, and that changes which function it calls. Let's go ahead and create that. It'll take a minute or two to spin up the resources, but it's usually pretty quick. In about a minute or two, it'll have the function in place. It'll have the API gateway. I don't know if Google calls it an API gateway, but just the endpoint to respond to. It'll have all those resources in place fairly quickly.
I noticed a requirements TXT tab on the creation page.
Yeah.
Is that, does it also look like the documentation seemed to indicate that it was a Flask request?
Yeah, so you can, and we'll probably get into this maybe in the serverless section. You can, in these inline editors, there's not a lot that you provide, but for when you use something like serverless, or if you deploy your own code to Lambda or Google Cloud Platform or Google Functions, you can package up, and they tell you how to package it up. In the case of Python, you do, I think it's a local install of the pip file or of the requirements.txt, and you package all that together. So it doesn't necessarily read the requirements.txt. Maybe Google Cloud Functions does, which is pretty interesting. But in the case of AWS, you have to install those all beforehand, and then package up that zip and put that zip out into the Lambda. But in the case of AWS, and probably in case of Cloud Functions, there's some libraries that come automatically. So in the case of AWS, you don't have to do anything. If you're, in my case for the cluster notifier, which I'll show here later, I'm really only using the Boto3 library, and Lambda has that prepackaged. And so you can call those libraries automatically. They're already there to be called.
Kind of curious if Flask was in that requirements TXT and the default function was really under the covers just a Flask route. It may not be, but just curious.
That's what it looked like, right?
Did seem like.
Yeah, I haven't done. I was curious about
So our function is up, and I'm just pulling up my command line here to make sure I get the curl properly. So we have an endpoint available to us now, and if we use that curl, and before I actually send the post, we'll just go ahead and curl the endpoint. This is actually hitting the function that we created. You see there that it responded hello world because we didn't pass in any message. And so in the next command that we'll run, we'll go ahead and, of course, I did that. We'll just go ahead and create it. I think it's we'll copy. So in this case, let's go ahead and now we're going to send the same curl, but this time we'll send a message of Python Frederick with a new line, and we're going to go ahead and make sure that the content type is application JSON, just so we know that it'll actually process that message properly. And we're going to do a post. It'll probably work with a GET, who knows? But it's the same function. So this time when we run it, we see that it responds with Python Frederick. We can change that message to be whatever we want, just to show that it's actually working. Python Frederick, this is a test. And we see it responds with Python Frederick, this is a test. We can go back to our function here. We can probably look at our general tab and see we've already started calling up invocations. And in this case, we've only had, what is that? I forget how that actually works out, but it's saying we haven't really had too many invocations, obviously. So let's pump up the volume on it and say AB, we'll use Apache Benchmark, which I was talking about serverless artillery. Apache benchmark just allows you to specify an endpoint and send a lot of requests to it really quickly. So let's go ahead and send 2,000 requests with a concurrency of 20 to our function here. We're sending some requests. That's pretty good. We're also probably setting up some alarms to my company's internal monitoring, so that's good. It's always good. We'll see. The interesting thing is I just created this function, so it's on Google's backend. It has seen these large amounts of requests come in. So you notice there it started slowing down, and in the percentage of requests received, about 100% of the requests, the longest request was 8.6 seconds. About 50% of them responded in 163 milliseconds. I bet if we run this again, or at least give it a second for Google to provision the infrastructure behind it, if we run that test again, it'll probably respond a little bit quicker. We'll try that out. It's not part of my demo. I just thought of it. We'll see what it does. I just want to see if it displays these invocations here.
Would that be a cold start for the first request?
No, I don't know if it's a cold start for the first request, but it hasn't really set up any of the load balanced scaling behind the functions. When you first turn it on, it's only reacting to what's there. There's probably, you're probably right. There's probably some cold start for the other instantiations of it. Let's go ahead and hit refresh and see if this shows up. We'll get to those invocations in a second. Let's go ahead and hit it again and see if it does any better than 8.6 seconds for there's probably some other slowness in this pipeline. It could be my laptop, it could be the internet, it could be my VPN. I just want to see if it responds any faster than 8.6 for the longest request, or I don't know if that's 8.6, but 86,000 milliseconds. Oh, hey, look, maybe a half a second faster. Who knows what that is, but anyways, let's see if this is showing us our invocations yet.
Your P95 improved, for sure.
What was the previous? Are you just saying that? Yeah, okay. What is that, 281 for the 95. What was the other one? Yeah. Still not showing this invocations graph. That's fine. We'll come back to that. If we go to the source here, let's go ahead and add in some. So we don't really have any. If we take a look at our logs, we don't really have any logging going out to it. So we can actually add in some logging just to help us debug. It's pretty interesting. So along with managing the infrastructure behind a serverless environment, you don't have to worry about the logging. The logging capability is there for you to look at. So here we can see, we had a bunch of different executions that were executed. All of those times that we hit that with Apache benchmark showed up in this function execution here. But there's not really much here in this view. If we take a look at one of these logs, it just kind of says, function execution started. That's about it. So let's go ahead and actually add in here. Let's do I think I have to actually put it in edit. That would help. There we go. Let's go ahead and add in a print request JSON. I think that'll work. Yeah. So now, previously in the logs, you just saw that it was doing some sort of execution. You didn't really know what it was doing. And now, in this case, every time we execute this function, it'll print out in the logs what the request was, and obviously still respond the way that it was supposed to to our request. And let's go ahead and click deploy. It'll go out there and deploy real quick. You can see here, pretty interesting thing. AWS does this as well. Allows you to see the different versions of your environment that's been deployed. I don't know the exact number, but it will show a certain number of deployments back. I don't really use the versioning capability, but it's there. If we wanted to revert back quickly, we could. So this should be, it's not out there yet. It's still in the process of deploying. I didn't realize I was going to do the majority of this demo from GCP. I think I'm going to have to turn in my AWS card. Don't tell them. I do prefer Lambda. I do. I just ended up showing this stuff from GCP size. Okay.
While you're here, do you mind clicking requirements TXT?
Yeah,
Satisfactory.
Looks like you could. I bet you I could put in some stuff here to have it, do things. We could probably play around with this later. Maybe add in like the request library and have it call HTTP bin as part of the function and return back what it gets from HTTP bin or something just to test that. So we've got that out there now. Let's go ahead and do the Apache benchmark. Let's, instead of sending 2,000, let's just send 200 so it's a little quicker.
I don't know that these are going to show anything, so you're not posting any JSON.
Oh, you're right. You're smart. This is why you're the leader here. Let's just see what happens though in this log. Yeah, so you're right. It did show that the text payload was none because we didn't send anything. So let's go ahead and let's just send a message in our last one here. Let's go ahead and we'll just send that last Python Frederick. This is a test. Let's see if that shows up in the logs. Can I jump to now? There we go. Hey, look at that. We've now got our message that we just sent. Python Frederick, this is a test. That wasn't in the other ones because we weren't sending a message, but that just shows, you can add in some debugging statements or whatever you need, and it'll automatically get picked up by whatever logging service is provided by the serverless environment. Let's go back to our slides.
Can I ask a quick question?
Sure.
So like, we're talking about micro functions together, like how much have you tested like that? Like how many functions can you put in that? Like,
So,
compared to big, like if maybe you said like a Flask idea.
Yeah.
Kind of like you have 15 endpoints, would you make 50 different functions?
It-
Or
it-
separate?
that's a pretty good question. I will be 100% honest with you. I haven't gone fully in the weeds into like multiple functions types of things, except for in one particular case, and I could probably pull it up a little bit later. I haven't really used it lately, but we built the meetup groups built a mapping application for the city, and initially we had built it as a Django app on a web server behind some load balancers and stuff. It was an infrastructure. It existed. It was fine. But then Matt actually brought to my attention there's a Django to Lambda conversion capability, and we actually converted. It was a couple of functions. I think it ended up being maybe 2 functions, and they were both provided behind an API, behind API gateway. And it was a Django app, but it was running in Lambda. And depending on which endpoint you called, and in both cases it was called from the JavaScript UI. You would call these 2 endpoints and it would provide you the map that you were trying to get. So in that case, maybe that answers your question. It was 2 separate functions that were provided behind an API gateway, and depending on which endpoint you called was which Lambda function you hit. But in some cases, these Lambda functions can get pretty in depth. There's a lot of different things you can do with them.
There's some kind of limit, right? Like, you can't time limit and how long they can run.
Yeah, so that was in the slide up here that you can't really see. It says, Max execution time per request for AWS is 900 seconds. For Azure, it defaults to 300 seconds, but it's upgradable to 600 seconds. I assume you just pay more. And then for Google Functions, the default is 60 seconds, and it's upgradable to 540 seconds. Yeah. So that was GCP. I tried to do Azure. I'm just going to skip Azure. It's not that I don't like Azure. I legitimately did try to build a demo for using the Azure console to deploy a Azure function. I got the base function created. I said it was going to be Python. I go to click this button to say it's to like create the Azure function, and it pops up this little error message, and it was a link to a GitHub. I could probably pull it up. It was a link to a closed GitHub pull request that said demonstration for Python via the console is now deprecated. I was like, whatever, fine. You don't get a demo. If you're like, it's not me saying I don't like Azure. It's just I wanted to demo this from the console. If you're not going to let me do that, then fine. I'm not going to show it. We've been talking about serverless, the what is it? The verb serverless, or is it the noun serverless? I guess it would be the verb serverless. There's also serverless, which is the serverless framework. And the serverless framework is kind of like it's an open source command line that allows you to templatize and set up some automated deployment of your Lambda functions, your Azure functions. They might support Azure, who knows? That might be deprecated too, for all I know. And GCP. I like serverless. There's some pretty interesting stuff there. Let me go ahead and just kind of show what you can pretty much do with this. Let me make sure. Let me make sure I'm in my right account. Let's go with dev. No, that's not the one. Yeah, let's go with that one. And let me make sure I get the commands that I want. Let me minimize. There we go. Much better. Because I can't remember all the commands, so I'm just going to copy. There we go. All right, so I've already pre-configured serverless. It's just a command line utility. You configure it with your different AWS profiles or whatever account that you're trying to authenticate it with, and then we just can go hello world create, and this will create. You know what? It's great if I practice this ahead of time. I think it's create, and then there, yeah. I just totally wrote that backwards. It's actually create hello world, maybe. What am I doing wrong? It's okay to Google.
Is it interactive or is it a flag maybe?
I think you're right. I got to pass in a flag. So I can do a template. Yeah, I don't want to create a template. I just want to create.
Name.
You see where it? Oh yeah, there you go. Man, we'll just go with this one. Watch it totally screw it up, but we don't want Node.js. There we go. Great, okay. So we've created some of our base stuff here. I'm going to move this Chalice demo out one. There we go. So that create command gave us these two files, the handler py, which we were kind of talking about earlier, and then the serverless YAML. The serverless YAML is kind of the important part of it. We've got a lot of information here. If you read through it, it kind of just gives you the name of the service that you want to call it. You can even dive down deeper into it to kind of answer some of the questions you had earlier about multiple Lambdas within a project. You can have serverless deploy different functions, all as part of a specific application. But in this case, actually, what this is application if you're registering it with the serverless dashboard, which I'm not going to get into. That's kind of on the serverless enterprise side. I'm just talking about serverless open source. And here where you can see it specified in the provider as AWS and the runtime's Python 3.8. You can get down into the weeds here and actually have the IAM role that you can specify if you wanted to, the different types of capabilities that you want it to interact with. We don't necessarily care about that. What I'm getting at here is this YAML file is what serverless uses to do the configuration of Lambda like we did previously via the console, where we just clicked a couple of things, typed in some stuff, and we created our Lambda function. With serverless, you configure all that via code. You can check that YAML file into code, and now that's a replicatable environment that you can have. Instead of clicking in the console and creating dev and then clicking in the console and creating production, you have that serverless configuration. You can maybe modify some environment variables for dev and production, but that one configuration file is what allows you to then say, let's deploy to dev, let's deploy to production. So let's see if the rest of my commands are jacked up. And of course, I didn't even actually, I think it's SLS deploy.
So this framework, this is not provided by AWS.
No.
Right, yeah.
The next one, Chalice, is provided by AWS. Serverless is provided by serverless.com, the serverless company.
Okay.
Yeah.
And it supports not just AWS, other.
Right. They support,
Custom providers.
there's a couple.
Yeah.
There is a couple that they provide.
Does that try to make it service agnostic?
There's, I mean, when you start getting into, when you are looking at like the IAM role stuff, which I kind of went over, or not went over, but mentioned and said we don't need to worry about it, that's definitely AWS specific. Like this is AWS, IAM is the identity access management. That's AWS specific. You can even see here, it's Lambda's function. It's very AWS specific there. If we used a different template, if we used GCP's Python template, there'd probably be, I think it's also called IAM, that would be Google specific. Does that answer your question?
Yeah, as far as your Python code, your requirements, dependencies, that's all the same.
I'm just checking to see what the different providers that I'm.
It's a good bunch.
Here we go. Infrastructure and compute providers. AWS Azure 10-cent cloud. Does that mean it costs 10 cents or is that something else? GCP. GCP must have paid more because their logo's bigger. Knative, Alibaba. An interesting thing, if you want a good laugh, take a look at Alibaba's services. It reminds me, it makes me think they just wrote a wrapper around AWS because they just copied all of it. Cloudflare, I didn't realize Cloudflare had services. What is FN? That's a good logo. It's so good that it makes you want to click it to figure out what it is.
Shark
Fin?
fin.
All right. Kubeless. I've heard a lot about Kubeless lately. From what I understand, it's you run a Kubernetes cluster and it'll do serverless, which is interesting to me. I'm a big fan of Kubernetes now. It's obviously a serverless talk, so let's carry on. All right, sorry. I was interested to see what other providers were out there. All right. Let's go ahead and do, did I skip the deploy? No.
And does the Is it safe to assume that the handler is like
Oh, yeah,
expected?
good catch. Let's take a look at this handler. In this case, it looks like we just have a function called hello. It has a body that it's generating, a response that it's creating called 200, and then it returns the response. Pretty simple hello world. Let's do SLS deploy. I think that'll actually work. Yeah, there we go. Cool. What we're doing here, you can see serverless is doing that packaging that I was talking about earlier, where you need to create a zip file for Lambda to put it up there. In that case, it's what it's doing. If we had a requirements file, it would download all of the different requirements that were required, and then and actually package them up and send it. We're also creating a stack and checking create or stack create process was doing there. Let's see if we can catch it in the process. It is using CloudFormation, which is another AWS service that I love. We have, yeah, there it is. Serverless example dev. So the name of the thing was called serverless example, and we called it our dev environment. That's all configured via that serverless YAML. And what it's doing here, serverless is actually using CloudFormation to create those resources. So it's all part of the infrastructure code side. It's doing the work of creating the Lambda. It's doing the work of creating the, let me see if I can get the different resources that it's creating. Why won't you scroll up? There it is. Resources, there we go. So we have 6 resources. I need to zoom out. I'm sorry. There we go. Good. So we've created a Lambda function called hello. We've created a, what is that? That is also the Lambda function. We've got serverless automatically created us a logs group, so we can look at the logs that it created that for. If you don't create the logs group, Lambda will run, but you don't have any logs created for you. It created that execution role that we were talking about earlier, where we can, if we really needed to, we could specify some different sources, different services that it could talk to, and it also creates this deployment bucket. So we were talking, you had to create that zip file to upload to Lambda. It's doing all that for us. We don't necessarily need to worry about that. And it's putting it in this deployment bucket, which it can then tell the Lambda to look at that deployment bucket to pull that zip file down. And once all that's done, we should have a completed stack. I'm pretty sure it's done. Perfect. So we have, as you can see here, all the information on our stack. If we go ahead and look at our Lambda console again, we should see, yep, there it is, serverless example. And here's, it's another example. And since it's such a simpler one, if you've got a pretty complicated Lambda function, it won't let you look at it in the inline code editor. We're not going to edit anything here, but you can see here that it's the exact same function we had before. We should be able to configure another test.
Now this one is another non-HTTP
Yeah,
function.
I'm pretty sure with serverless we could specify just to create an API gateway endpoint, and it would do that for us automatically. I don't think it did, but I'm going to get to that in Chalice anyways, so it'll be fine. I don't think, yeah, there's not an API gateway endpoint here, so we'll just test it from here. We'll see that it'll respond. Yeah, so status code 200, and the body was serverless 1.0. But the interesting thing is, since we're using serverless now, we can update this handler. We can change the body to say whatever we want. Let's change this to say Python Frederick, and we'll do another deployment.
So it will work with the existing stack rather than create some new stack?
Yeah, exactly. So we're going to do this deployment, and it will say, hey, we're going to upload the artifacts, and we're going to do an update this time. Instead of a create, it's going to take the existing stuff. It uses the stuff that was created with CloudFormation through the serverless deployment. It says, hey, I know this stuff already exists. I just need to update this specific thing. It'll go out there, and it's already updated. We go out here, let's do another test, and this time it responds back with Python Frederick. When you use something like serverless, I'm not saying you have to, I'm saying when you use a serverless management utility with something that you can put in infrastructure code, that simplifies the whole rest of the process. It allows you as a developer to focus on the writing of the code, so you don't have to worry about the infrastructure. You don't care about the infrastructure. That stuff, it's supposed to work. You don't need to worry about that. You focus on the code, you figure out the next Uber, the next Facebook, or whatever. Deploy it out to some serverless environment, doesn't matter where it is AWS, Azure, GCP, probably not Azure because you can't figure that out. But as long as you get to focus on the code, you're writing that next thing, you deploy it, and you're able to make the changes instantaneously, and you're good. Like that's as simple as I can make it. I mean, it's you abstract away the need to worry about the infrastructure so you can focus on writing the code, and your life is so much simpler.
Question.
Yeah.
So I haven't done a lot of like serverless stuff, but I thought of one of the limitations that you have, at least with the websites and things like that, so you can't make like dynamic content. Everything has to be like static. Is that the case?
So with serverless, you can make it all dynamic. The big difference though with serverless is you're not necessarily able to generate like HTML that'll load into a page. We were kind of talking about it a little bit earlier with the web app that we made for the city. You have that static JavaScript that calls the API endpoint. So that static JavaScript is, maybe displaying what's responding from a Lambda API gateway. The dynamic side of it is the Lambda stuff that's maybe looking at a database, pulling out information, and then sending a JSON response to the static JavaScript, and then the static JavaScript makes it pretty on the browser. Does that answer your question? Great. So that was serverless. Chalice, I like Chalice. It's AWS, it's provided by AWS, and it's a Python application. And so what's really interesting there is the Chalice deployment will create the API gateway endpoints. If you specify any IAM roles or any IAM service or any AWS services that you need to talk to, say you're trying to talk to a DynamoDB table or some other database capability, it'll automatically generate that IAM for you and make those roles automatically. And it's just kind of like an all-in-one. I will say it's lacking some features that serverless has, but as you'll see here, it's incredibly easy to get started. So I'm just going to actually start from fresh. I'm going to not even use the Chalice demo that I created earlier, and I'll just do, let's make dear. I'm going to use pipenv. We'll see how that goes. The interesting thing was, a couple of months ago, Kenneth Reitz was here demoing pipenv from my company laptop. I had to report that later, which was pretty funny. But he did the install, and it took forever to install pipenv. And he's just sitting there like, this is the longest it's ever taken. And I think he went out after that and made pipenv run a little bit faster. So you're welcome. So let's go ahead. We've got our pipenv environment. Let's go ahead and install Chalice. It's a Python package. This is the part that takes longer. No, I'm just kidding. How are we doing on time? Yeah, we're almost there. Great, okay. So we've got Chalice installed. We'll go ahead and we'll just go ahead and use pipenv to create a new project called Hello World, and we'll cd into Hello World. And with that Chalice new project, Hello World is just creating this this folder here with all this stuff in here. The Chalice directory, I think, is where Chalice stores some of that state that you need to know about to be able to interact with the resources that it creates. Don't worry about the get ignore. Ignore the get ignore. And then the app.py, I'll show that here in a second. Then a requirements text like we would expect. You know, we can, with Chalice, you put in here whatever you want to, and Chalice will go out and package it for you. Let's look at this app.py. The interesting thing is a lot of these different templates, they all end up using Flask. I think this is Flask as well. Yeah. So in this hello world, we just have an app route of / and it returns hello world in a JSON package or JSON brackets, whatever that term is. I guess this just returns JSON. We can go ahead and do pipenv chalice deploy. And just like serverless, it does all the work. It creates the deployment package. In this case, it's going to create an IAM role because Lambda needs to run with an IAM role. It creates the Lambda function. In this case, it's called hello world dev. And then it also creates an API, and it tells us what that API gateway endpoint is. We can curl that, and there you go. Hello world gets responded back. Let's go ahead and update app.py. Let's change it from hello world to message Python Frederick. Let's do another deploy. It'll go out there and update everything. All the endpoints are still the same, but in this case, we're going to get a response, and you see that it just changed to Python Frederick. The other interesting thing, at least with Chalice and serverless, also provides this is I'm going to try and get it right. You can actually invoke it from the what's it called? Terminal. You can invoke the Lambda from your terminal. So maybe you don't necessarily care about hitting the API. Maybe there isn't an API that you want to hit because you're doing some sort of event processing. So we'll go ahead and just call the actual Lambda itself. I can't figure out the name of this thing. Give me 1 second. That's the name of it. Why is that not working? Well, basically, if I could figure this out right, doing an invoke would just run it on the system itself. I think, if I'm not mistaken, Chalice also allows you to, and I don't know that serverless lets you do this. Maybe it does. I'm going to double check. There it is. We can actually do Chalice and run it locally. So instead of running in the Lambda, I'm able to now use this endpoint here and curl it locally. So there's message Python Frederick. We see we just got the GET request there. Let's go ahead and has that been there the whole time? Wow, you guys could have said something. My little window browser down there, or the little selector, was sitting there blocking me. Let's go ahead and this time let's go ahead and update this. We'll change this to Frederick Python. And this time, just to show, so we updated the app.py. We're not going to deploy it, but let's run it locally. And if we hit it again, we see Frederick Python there. And if we go back to the curl endpoint, we see that what's still deployed is Python Frederick. So locally, we can hit it and get Frederick Python. If we hit the actual deployed endpoint, it's Python Frederick. So yeah, serverless is pretty interesting. I think that was all. Yeah, that's it. So that was Chalice, and happy to answer any questions.
You mentioned that it can read environment variables.
Yeah.
How would you set those?
It depends. You want to set them in serverless? You want to set them in Chalice? Do you want to set them via the?
Well, like say it was like secrets or something that you want to
Yeah.
put in as few places as possible.
Good, actually. You made me remember I have one more demo. Thank you. Because in my cluster notify, think it's that. Yeah, there we go. In my serverless, in my deployment here, we specify environment variables. And so here is two environment variables. One is the channel that the cluster notify capability posts to, and in our case it's the cloud infra channel in Slack, and then the Slack URL. Obviously, I don't want to publicly expose this Slack URL. And so I can specify in serverless, I can specify to tell it to look for a file called serverless environment YAML. And if you look at the git ignore, serverless environment YAML is specifically set to git ignore, so I don't accidentally commit that. And that's just a very simple YAML that's got these two environment variables in it that's stored locally on my system.
I see. So
That-
you don't have that file in your Git repo, but it's in
Right.
your directory before you run the
Yep.
Chalice or whatever.
Right. And in a case of using something like TeamCity or Jenkins, we can modify that to make those environment variables that are passed in to the serverless deployment if it's deployed as part of Jenkins or something like that. When serverless does this deployment, it creates those environment variables, and in this case, reads it from that YAML file. In the case of this, just one of these tests here, you can specify environment variables right there.
So is that some kind of AWS resource type, an environment variable for function?
No, they're just they're
To that?
it's a key value environment variable. The GCP's got the same thing. Let's see if I can find it.
So it's associated specifically with that function instance.
Right. It's not like globally out there. It's that function specifically knows what those environment variables are. I'm not going to be able to find it in GCP, I don't think. Maybe. Oh, here, environment variables, networking. So one thing I didn't really get into is there's a whole slew of like networking things that you can do with Lambdas. They now have, at least Amazon does, you can run Lambdas locally within a VPC, so they're not necessarily exposed publicly. They're running in a private portion of your cloud, which is pretty interesting too. But yeah, here's where you can specify environment variables for GCP. Just again, name and value, key value pairs.
You want to mention Zappa?
Yeah. Let me see. So Zappa is the serverless Python Django, and it looks like it says Flask apps too. The interesting thing about this was we had for that city utility. It was a Django app running on an EC2 instance behind the load balancer in case something happened. It would auto heal itself, and it cost, I don't know, $30 a month or something like that. Using Zappa, you just run it on your Django project, and it figures out how to deploy it just like Serverless or Chalice did. It deploys it for you automatically, and it creates those Django endpoints. And we were able to remove that entire infrastructure and have it just responding via Lambdas, which was super awesome.
How does it handle the database?
So in that particular case, there was no database. What it really was a wrapper around an existing ArcGIS mapping database that the city provided. We just built a wrapper to make it easier to, actually, I think it might still exist. Watch this not actually work. Hey, there it goes. I don't think this is going to work, but I'm going to zoom in. Because it's been like 2 years since I touched it. So you can zoom in on a specific section, and then we filter, we specify the map type, and let's hit export. Come on. Oh, of course, it doesn't work. So what was supposed to happen there is that little broken image icon shows the image that we just tried to export out of the city's utility, but it hit two Lambda endpoints out there. The Lambda side of it is still working. It's the city's server that's not working. Long story. We'll get into that later. The city's IT department is great. If you're listening, I think they're great. Any other questions?
Yes, Patrick. In the history of cloud computing, where did serverless start? I thought just by its very nature, cloud computing was serverless. Was there a time when people could manage their own servers on the cloud?
Yeah, I mean, you still can manage your own servers in cloud. With AWS, you have EC2 instances. You spin up those instances. They give you an IP address. You log into them. You install whatever you need to install. It could be Windows instances. It could be Linux instances. They're there for you to manage if you really want to.
And is it limited by like a certain amount of space or something, or can they just give you what you need depending on your demand?
For AWS and GCP and Azure, actually all three of them, you specify instance sizes. So you can, in AWS, provision, I think, like a 4 terabyte instance. If you really wanted to, it costs like $40 an hour. Or you can configure a T2 micro instance, and you're spending like less than a cent an hour. As it obviously, depending on how much you pay, is how much resource you get out of it. If you really wanted to, you could spin up your own infrastructure in AWS, install a thing like OpenStack, and then deploy the OpenStack serverless.
I don't think you want to do that visualization on the
I mean, what is it? I think it's FAS. Yeah, functions as a service. So you're essentially creating your own, you're managing your own infrastructure, and then you're managing your own functions as a service on your own infrastructure. I mean, that'd be pretty crazy. Dan Roberts has probably done it.
I've done them separately.
He's a big OpenStack fan.
Nope.
Done that. Yeah, we're doing it for a couple of years. It's horrible.
Did I answer your question? Perfect. Any other questions?
In terms of performance, you said I guess you could pay more for like some special function that you wanted to be like really fast or something.
Well, so actually that's another interesting aspect. So really all we've interacted with AWS, I don't know that the other providers provide this yet. With AWS, what we were really interacting with was just the core Lambda service. You can actually, with Lambda, use what's called Lambda at Edge. And what that does is there's Amazon has what's called points of presence. So what you normally interact with are the different regions that AWS provides, but then they have like 22 different regions all over the world, but they also have 200 or 300 points of presence. So there's probably a point of presence in Frederick somewhere. There's a point of presence out in Alaska, or it's not really a data center. It's like a portion of a data center that AWS purchased and put some resources in. With Lambda at Edge, you get what you're looking for, which is that maybe not so much higher performant, but faster response times. So when you're interacting with a Lambda in, say, US East 1, when you make that API call through API gateway to the function, you're talking maybe 100 milliseconds of latency. If you use something like Lambda at Edge, you do pay an additional dollar amount. I don't remember the exact percentage or dollar increase on Lambda at Edge, but now that Lambda is actually running at one of the points of presence. So let's say maybe it's in Frederick somewhere. Amazon has built the infrastructure in such a way that when you make that call, it talks to that point of presence Lambda. So instead of 100 milliseconds, maybe it's 25 or 5 millisecond response time. Does that answer your question? Perfect. I don't know if GCP or Azure has that. It's pretty interesting. I haven't used the Lambda at Edge yet, but the idea of removing the physical distance between the person making the request and the thing that's doing the execution obviously reduces the response time for things. And that's pretty interesting to start moving that processing power closer and closer to the person.
I think that's what Cloudflare is doing too. They're trying to get into edge computing.
Yeah, it's really interesting. Amazon just announced. So I mentioned, I'm not trying to make this an Amazon talk. I'm obviously a big fan, but they just announced, this is what blew me away. You have regions. In regions, you have availability zones, but now they're starting to create local zones, and they have their first local zone in, I think it's LA, and so you can specify that your stuff runs in a specific city. It's getting interesting.
And that local zone means like a specific data center, or it could be different data centers?
I think the closest they're going to get you is like a specific area that you want to run in. And so in the case of the LA local zone, you say, I want to run this in LA, or I want to run this in Baltimore, or I want to run this in
San Francisco.
Portland, Maine.
You want to run through a third party or on the?
That's their infrastructure, yeah.
They have lots of nondescript data center buildings all
Yeah.
over the place.
Yeah.
They won't tell you where some of the lockbox really are. They're secretive about it for good reason.
This is really exciting. I built out a Flask app a few months ago, and I'm gonna
Just-
rewrite it all now. It's
Yeah,
serverless.
yeah.
I'm so excited.
Check out Zappa, because you probably don't have to change a single thing, and Zappa will just,
What it does is it takes, you know, Python apps, most of these big frameworks, Django, Flask, Pyramid, whatever, they use the WSGI, web server gateway interface, and Zappa interfaces with WSGI, so it kind of like wraps up all your stuff, makes all the API gateway, and just knows how to talk WSGI, and does the translation for you, so you basically get your app wrapped up in serverless for not a lot of work.
Awesome. I'm super excited about this because we're using AWS to do it.
Yeah.
CloudFormation entities to it, it's a static. So it's like, it's so nice that we just, because we only need this service every now and again, but the infrastructure as code there.
Yeah.
Nice.
don't worry about the infrastructure. Let Amazon use it. Now, you do end up paying more by letting Amazon take care of that, but they're going to do a better job of it. The better part of it is, think of that EC2 instance that you have out publicly exposed. That's a potential security hole, you know? Okay, but it's out there.
It's out there.
It's out there. With something like Lambda or a managed service, AWS is taking care of the patching. Well, sorry. The cloud provider's taking care of the patching. They're taking care of the scaling. They're taking care of all the things that just allows you to focus on the code.
Yeah, like when we did that project for the Map Frederick project, we took the cost like down to basically nothing.
Yeah, because it was per request. If nobody uses it, it doesn't cost anything, except for a little bit of storage.
Can the events be as simple as just like a time, like a cron job?
Yeah, I didn't show that, but that's basically, actually I'll show it in my cluster notifier here. So in this serverless YAML for this cluster notifier, and I didn't really show this. This is just a simple utility. Goes out there. We look for, I set up just some basic init stuff to say I want the environment variable Slack URL. I create the username for the Kubernetes bot, or it's called KubeBot, just to say, hey, there's some stuff out there. We get a list of all the regions. We get a list of running instances. From the running instances, we get a list of the ones that are Kubernetes related. So through here, we're looking for tags that have kube cluster or Kubernetes cluster. If that doesn't exist, we're checking for this other tag. In both cases, we just generate the specific instances that are Kubernetes related. We get the uptime from all those instances and then consolidate it down and then actually craft a message to send to Slack to tell us these are the clusters that are online. But to answer your question, basically through this serverless YAML, you can specify in AWS at least a schedule, and it runs at a rate of once a day. It just runs that Lambda. And this Lambda costs us $0. Yeah. Yeah. I like it for, a long time ago, if I had like some operational things that I needed to do on an account or on some instances, I would run it in Jenkins and I'd have Jenkins do the work. Now I see myself actually writing a lot of it in Python and running it in Lambda, because now I don't even have to worry about that job in Jenkins and making sure Jenkins is online. I have it running in Lambda. I don't have to worry that Lambda's there because Lambda's going to run, and it just does what I tell it to do.
You could apply the same logic to GitHub Actions too, which is GitHub's new. So if your code's already in GitHub, you could use GitHub Actions to do cron kind of stuff.
Yeah.
As well.
Does it tie into like AWS and stuff? Like what does it run on?
GitHub's owned by Microsoft, so it's probably running on Azure and the covers, but it's a CI service that is available for any project for free to a certain level.
Yeah.
It's running in the US.
What's that?
They're still running in the US.
Oh, really? Okay.
Most of their stuff, yeah.
All right, cool.
So that's serverless. Give it a try. It's not going to solve everything. It'll make some of your life easier, truthfully. For prototyping, it's great. Just deploy your code, test it, and then when you need to do something real with it, put it in a Kubernetes cluster or something, you can kind of do that. Or just leave it in Lambda and let it do its thing in there. It's pretty good.
Thanks, Patrick.
Yeah, thanks.